we have seen that the multiplication of tensors is of two types. The first one is known as outer product of tensor and the second one as inner product of tensors. And in the first lecture on multiplication of tensors, you have discussed the outer product of two tensors or more than two tensors. Now today we will see the concept of inner product of tensors. So first of all we will see how this inner product of tensors is defined, and then we will learn how the inner product of tensors are found. Actually, when you say inner product of tensors, that means it is a process to find the, first of all, outer product of tensors, and the tensor which is obtained after the outer product, that suffers a contraction. It means the process of outer multiplication of two tensors followed by a contraction gives us a new tensor, and that new tensor is called inner product of the given tensors, and the process by means of which you obtain the inner product of two tensors, that is called inner multiplication. So from this definition you can see how the inner product of two tensors can be found. So if you wish to find the inner product of two tensors, first of all find the outer product of the given tensors. In first step, what you will do, you will obtain the outer product, and you know how outer product is found, you have seen in the previous lecture. And once you get the outer product of the given tensors, then apply the process of contraction. You know how contraction is applied. In fact, for applying contraction, we simply set one contravariant index and one covariant index equal, and then the repeated index is summed over. And you know, after contraction, the rank of the resulting tensor is reduced by 2 or lowered by 2. So when we take the outer product of two tensors and after that we apply the process of contraction, then the resulting tensor will have a rank lowered by 2 from the rank of outer product of the given tensors, and that resulting tensor is actually known as inner product of the given tensor. So what we have learnt in this rule, we will clarify that by taking a proper example. So let us consider we have to find the inner product of two tensors which are in fact A and B, which is defined like this. So let we have to find inner product of the tensors let us say first one is A super ij sub k, and another tensor is B super p sub q. These are the two tensors whose inner product is to find. Now follow the step. In first step, what you will do? First of all, we will find the outer product of these two tensors. You know, the outer product of the given tensor will be equal to what? That will be simply A super ij sub k times b super p sub q. And you can see this is just a tensor or mixed tensor, you can say, of rank 5. In fact, the rank of tensor A is 3 and that of B is 2. So this is a tensor of rank 5. Tensor of rank 5. Now, to find the inner product, what you will do? We will simply apply the process of contraction. And in contraction process, you know, we set equal one of the contravariant index and a covariant index. So in next step, we will follow the process of contraction. Sorry. Yes, we will follow the process of contraction. And in contraction process, you can see here, we will simply set the indices P and K equal. So, putting P equal to K, P equal to K. Then what will be your result? You can see the product is this much, and now we have to take P equal to K. So replace P by K, and then you will get A super ij K and B. Instead of P, now we will write K. So KQ. And you know, when we will sum over the repeated index K, this tensor is actually a tensor of rank 3, not 5, because the repeated index is not counted in the rank, you know. So this will be just a tensor C super ij sub q. And you can see this is just a tensor of rank 3. So as you can see, the rank of the outer product of these two tensors was actually 5. Here you can see this rank is 5, but after taking the inner product, that is following the process of contraction, we see that the rank of the resulting tensor becomes 3. So rank has been lowered by 2. Now again we can follow the process of contraction. So if you wish to again apply the process of contraction, then we have to set again equal one of the contravariant index and a covariant index. So again, if we put P equal to K, this has been already taken before, and now we take J equal to Q, because you can see J is the contravariant index and Q is the covariant index. Then what will be the resulting tensor? You can see this will be A super IQ. Instead of J, now I am writing Q here, you can see, and K B K Q. Now the repeated indices are K and Q both, so they will be summed over, and so the resulting tensor will be simply D super I, which is a contravariant tensor of rank 1, or you can say contravariant vector. This is just a tensor of rank 1. And if you follow the process of contraction one time, then you get a tensor of rank 3, and if again you follow the process of contraction, then the inner product becomes a tensor of rank 1. So this is the technique to find the inner product of two given tensors. Now in this regard, let us solve a problem. You can solve a problem to clarify the idea of inner product of two tensors. In this problem, we have to show that the inner product of a tensor A super P sub Q and B super Ij sub K is a tensor of rank 3. We have to prove this. In fact, such problems are solved by the technique of transformation law. So simply we will first of all take the outer product of these two tensors, then apply the process of contraction, and we will see that the resulting tensor will follow the transformation law of a tensor of rank 3, and which will prove that the product of inner product of these two tensors is a tensor of rank 3. This is the technique. So let us first of all find the outer product of these two tensors. So outer product. What will be the outer product? You can see this is simply A super P sub Q B super Ij sub K. This is actually the outer product of the given tensor. And now we will apply the process of contraction to get the inner product. So if you want to find the inner product of these two tensors, then what we will do? We will set equal one contravariant index and one covariant index. So let us put here I equal to Q, or you may also take J equal to Q, anyone you can take. So to apply the process of contraction to get the inner product, let us put I equal to Q. So when we will take I equal to Q, this inner product of these two given tensors will be what? This will be A super P sub Q and B. Now instead of I, we will write Q, so Qj K. Now we have to show that this resulting tensor is a tensor of rank 3. You have to show that this is a tensor of rank 3. We have to show. So now let us consider the components of this tensor which we have obtained by setting the indices I and q equal in the primed coordinate system. That is a coordinate system in which the independent variables are, let us say, x prime I. That can be obtained by following the proper transformation law which we have learnt in the previous lecture. So let these components are A prime PQ, B prime QJK. Now, if you want to write the transformation law, let us see. For this tensor A prime PQ, we will write its components in the unprimed frame as AUV, and partial derivatives will be what? You can easily say this will be del x prime P by del XU times del XV by del x prime Q. You know. In fact, this is actually the transformation law for the tensor A prime PQ. Now, this will be multiplied by the transformation of this tensor B prime QJ. And so, let us consider the components of this B prime QJK in the unprimed coordinate system is, in fact, let us say B R S T. Then see the type of tensor and apply the transformation law. You can say this will be del x prime Q by del XR, you know, del x prime J by del XS and times del XT by del x prime K. Now we will simplify the RHS of this equation a little bit. You can see this will be A UV times BRST and del x prime P by del XU and del x V by del x prime Q and del x prime Q by del XR. You can see. Let us associate these two terms, and after that there will be del x prime J by del XS times del x T by del x prime K. Now, see here, this del x V by del x prime cube times del x prime cube by del XR, you can see this del x prime q and del x prime q will cancel out, and del x v by del x r, this will be simply equal to the Kronecker delta Vr. But first of all, we will write it. So just repeat the term here. So you can say A prime PQ times B prime QJK, this is equal to, see the equation, this is this much. So write those things at each. This is A UV times B RST and del x prime P by del XU. Del x prime P by del XU. Del XU. And in this bracketed term, you can see this will be del x v by del xr. Del x v by del xr, because del x prime q will cancel out. And after that, del x prime j by del xs, del x prime j by del xs, and del xt by del x prime k. Del xt by del x prime k. Del x prime k. Now what is this? Can you say? This is nothing. This is simply the Kronecker delta Vr. So we will write here A UV BRST, and instead of this del x v by del xr, we will write the Kronecker delta Vr, and the remaining factors are del x prime P by del XU times del x prime J by del XS times del XT by del x prime k. Now when V is equal to R, then this Kronecker delta will be equal to 1. So if V equal to R, then delta Vr is equal to 1. Otherwise this will be 0. So to get a non-zero result, we have to set equal V and R. And therefore our result will be A prime PQ times B prime QJK equal to A UV sorry, we have to set V equal to R. So instead of V, now we will write R. So instead of this V, you should write R. So AUR times B RST, and Kronecker delta will be now 1. So I am not writing it, and the remaining factors are del x prime P by del x U times del x prime J by del x S times del x T by del x prime k, del x prime k, del x prime k. Now you can see this equation is nothing. This is simply the transformation law for a mixed tensor of rank 3, because here you can see there are 3 partial derivative factors. So this is simply the transformation law of a mixed tensor of rank 3. And that's why you say that this tensor, that is A, P, Q, B, Q, J, K, this is actually a mixed tensor of rank 3. So you can say this is the law of transformation, law of transformation of a mixed tensor of rank 3. And so you can say that the tensor A, P, Q, B, Q, J, K, this is a mixed tensor of rank 3. Mixed tensor of rank 3. And so the problem is now solved. You can see actually in this problem we have to show that the inner product of A, P, Q and B, I, J, K is a tensor of rank 3, and its outer product was actually 5 and inner product is 3. And if you will again take one contraction, then you will get that the resulting tensor will be of rank 1. But I am not doing that. This is just a homework for you. In fact, you have seen in the outer product some of the important properties of the outer product. In fact, like those property, this inner product of two vectors is also commutative and associative. It means the inner product of two tensors follows or obeys the commutative and associative law of algebra. But I am not explaining that. This is just a homework for you. You can see that the inner product of two tensors is commutative and associative.